Hello everyone, my name is Shrabani Garai, the student of Bolpur College. Today I am presenting my dissertation. The topic is photochemistry and its importance. What is the photochemistry? The photochemistry is the study of interaction of electromagnetic radiation with matter resulting into a physical change or into a chemical change. This is called the photochemistry. The Giacomo chemician is regarded as the father of photochemistry. The principle of photochemistry, the study of interaction between atoms, molecules, and light. The photochemistry is concerned with absorption, excitation, emission of photons by atoms. The absorption band, the shorter wavelength transferred to larger wavelength by absorbed photons. Bodenstein pointed out that the photochemical reaction involved in two distinct processes such as primary and secondary process. Primary photochemical process, in which the light radiation is absorbed by an atom, giving rise to the information of the excited atom. Based on the relationship between the upper and lower electronic level, the four types of primary processes are possible. Type 1. In this case, the vibrational energy of the molecule in the upper electronic state exceeds the maximum value, which leads to dissociation of molecule in its first oscillation. Type 2. The molecule is simply excited to the upper electronic state. The electronic spectrum consists of a series of bands with no continuous region. Type 3. The molecule is again dissociated as the upper level, they represent an unstable state. Type 4. In this case, the stable and unstable upper level overlap each other. Transition occurs lower level to stable upper level. During a course of vibration, the molecule is switched over to unstable one at the point where two levels are cross each other and the molecule then dissociated. This behavior is referred to as pre-dissociation. In the pre-dissociation, the rotational lines are absent and vibrational bands have diffuse appearance. The secondary process. It refers to the subsequent reaction that occur after the initial photoexcitation event. This process involves the interaction of the excited state molecule with its environment, leading to various chemical transformation. It may involve in one step or more than one step. The example is decomposition of Ag. The reaction is laws of governing absorption of light followed by Lambert's-Beer law. When a beam of monochromatic light is passed through a solution of an absorbing substance, the rate of decrease of the intensity of radiation with thickness, the absorbing solution is proportional to the intensity of incident radiation as well as to the concentration of the solution. The mathematical law is A equal to epsilon LC. A is the absorbance, epsilon is the molar extinction coefficient, L is the path length, and C is the concentration of the sample. The Lambert's-Beer law mathematical expression may be expressed as below. The ratio I by I naught is called transmittance and log I by I naught is called optical density or absorbance. The basic law of photochemistry is two types, Grotthus-Draper law and the law of photochemical equivalent. The Grotthus-Draper law states that only those radiation which are absorbed by reacting systems are effective in producing chemical change. The second law is the photochemical equivalence, which is proposed by Stark and Einstein. The law states that each light absorbing molecule in a photochemical reaction absorbs only one quantum of light, which causes activation. If the mu is the frequency of the absorbed light, its energy is as given by Planck relation delta E equal to h mu. The energy absorbed per mole of the substance is delta E equal to NaH mu. This quantity is known as Einstein energy. What is the quantum yield? Quantum yield is the important parameter in photochemical reaction. The number of molecules reacting per quantum of light is absorbed. This is called quantum yield. It is denoted by phi. The phi equal to rate of conversion by rate of photon absorption, and the amount of substance reacted by amount of photons absorbed, or phi equal to number of molecules reacted by number of photons absorbed. The region of high and low quantum yield is depend on the secondary process. or not primary process, because in the primary process the quantum yield is always 1. A molecule absorbs only one photon for its excitation, according to Einstein's law of photochemical equivalence. The reason of high quantum yield. The high quantum yield in the free radical gives a chain reaction, and due to formation of intermediate product which act as a catalyst, and after the absorption of radiation the activated molecule which is formed may collide with other activated molecule. For this reason the quantum yield is always increases. Example is the decomposition of AGI. Low quantum yield. The excited molecule may be deactivated through the fluorescence and phosphorescence. Excited molecule converts its energy into kinetic energy. The primary photochemical process may get reversed. For this reason, the quantum yield decreases. The example is dimerization of anthracene. Jablonski diagram. The Jablonski diagram is a simple energy level diagram. In 1935, Polish physicist Alexander Jablonski was first proposed it. It illustrated the process of phosphorescence and fluorescence, helping to illustrate the difference between these two phenomena. What is the fluorescence? Fluorescence is the process where a substance absorbs light at a specific wavelength and then emits light at a longer wavelength, typically within the nanosecond. It is a spontaneous process. What is the phosphorescence? A substance absorbs radiation of high frequency and emits light even after the incident radiation is cut off. In the ground electronic state, a molecule is generally a single state, and this is represented by S naught. When a molecule in the ground state absorbs a photon, it is raised to one of the several singlet excited state is represented by S2 or S3. After the excitation, the two electrons which were originally in same orbital and are now in different orbital, and the Pauli exclusion principle is no longer applicable. Now the spin of one of the electron may be inverted to produce a triplet state. The energy of triplet state is always lower than that of the corresponding singlet state. The electron in the triplet state have same spin, and therefore electrons are repelled to each other, and hence the energy of the molecule decreases. The excited molecule can return to the ground state by losing their excitation energy in any of the following ways. When excited molecule may lose a part of their excitation energy in the form of heat because of collision with other molecules. As a result, the molecules moves to an electronic state having lower vibrational energy. This process is called internal conversion. When the excited singlet molecule may undergo a change in spin orientation giving lower energy triplet state. This change of a singlet state to triplet state is called intersystem crossing and involves radiationless transition. Emission of radiation due to transition between two states of same multiplicity is called fluorescence, and the emission of radiation due to transition between two states are different multiplicity is called phosphorescence. What is the luminescence? The emission of light by a substance not resulting from heat but rather from a chemical reaction, electrical energy or other excitation process. This is called luminescence. It is 7 types. Chemiluminescence. When light produced by chemical reaction at ordinary temperature, the example is glow stick. Fluorescence emits light only while the substance is exposed to an external light source is typically within nanosecond. Phosphorescence. When emits light for a longer duration after the external light source is removed, typically within millisecond to second. Bioluminescence. When the light emits through the biological process, example is fireflies, glowworms. Electroluminescence emits light when an electric current is passes through a substance, example is LED. Radioluminescence emits light due to ionizing radiation like in radioactive material. Sonoluminescence emits light when a substance is excited by sound waves. Application. Photochemistry plays an important role in living organisms. It has numerous applications in various fields, like as photosynthesis, When the plants absorb solar energy to convert CO2 and H2 into glucose and oxygen. Bioluminescence for photodynamic therapy is a light-based treatment for cancer patient. Formation of vitamin D. The solar light is essential in a human body to formation of vitamin D. Photovoltaics. The photovoltaic cell conversion of light into electrical energy. The example is solar cell. Photopolymerization. Environmental remediation. Food and agriculture. It is a light-based food processing and preservation. Photocatalysis. The pollution remediation, water purification, and chemical synthesis. And it is used in material science and energy storage, cosmetic and skincare products, atmospheric science, and the forensic science. Here is my acknowledgement. Here is my reference. Thank you.